My name is Liat Pele. This is a work that we have done together with my husband that could not be here today, could not join, Dr. Ofir Pele. And it's a project of my previous position with my manager, Udi Buchko, which is totally supporting, and my core group, Tal Kabinsky, Shachar Arad, and Odea Berger, and Shoshana Priest. So this is the story. I would like to start about talking about health check for SREs and why it is important. Then talk about QE for health check for SREs and why it is critical in this context. We are interested in the question of which validations are the most important to be manually verified, are the most risky. And then we'll talk about feature extraction from code and Git, and then utilize some classical machine learning for tabular data. And we'll see some advantage in this field that we done for this project. So cluster, as they are very complex and complicated, tend to have issues. And the usual loop is that SRE engineer engage with the customer, fix some, find the issues, set some workaround, and after the issue is finished, come to our group and contribute some validation code for our validation tooling. And our validation tooling is then back to the field, and this is ongoing cycling, which we are running for the last 3 years. We found this is reducing dramatically the cost of failure. We found a lot of occurrence, and of course, it's a great tool for knowledge sharing. The way we are working, we have a core development group. And we're sitting in, here. We have a core development group which sit inside the support group, and we make everything play together. We are responsible for the engine, we support users, and we are responsible for the CI/CD. And in this context, we mainly work on the QE part. Okay, a word about our users, our support users. Support engineers is hard customers. There are a lot of time working in pressure, and they need to have some trust relationship with the product. For that, our tool must be very robust to system which is not on their best, and the result should be reliable as much as possible. It is reminding me a lot of time medical doctor, as time of pressure, in many cases, they will go back to the very simple stethoscope, which is not very sophisticated, but very reliable. As for now, we have more than 400 different validations, which we maintain all the time on a monthly basis. Around new validation is being added every month. And this will be our source of knowledge. Quality. So one aspect is that the tool will run, that we can know it's working. But from result point of view, we can think either of false positive. That means that the tool suggests there is an issue in the system, but the system is fine. They can be a false negative, which means that we said we checked something, but we actually don't. And then it can be something like we could not run. The system assumptions were not fulfilled. It can be like one parameter in a configuration file that we check, but the configuration file itself is not there. How we strive? We strive to, of course, to lower all those numbers for the false positive, and for the third type, we can use a nightly test that we will show in a minute. unit test and feedback from the users. The third part is a little harder because it's hard to test and hard to get feedback from the users. Of course, we strive to decrease all of them. So this is how our nightly check looks like. This is from 2 days ago. It is really low number of rules to check. Every morning, one of our group, this was a Swagata, is checking the status. We run all the rules on all the setups, both from QE, R&D, and support. And every morning, we check if there's new failures that we didn't see before. And this is manually and tedious work. We don't like so much manual. But one of the things that we really wanted, we wanted to know where to focus, who is the most important to look at. In many cases, this number is like 40, and we decided that we spent 1 hour on shift each one, and we want to know on which order we want to see the rules. And this brings us to an interesting research question, which is, can we rank the validation according to the likelihood of need a future fix? And it was a good opportunity because we had a data set that is repeating. Each validation is written in similar structure. We have amount statistical group, which I thought it's big enough, hundreds, and we are maintained for several years fixing. So I started with looking at my group and see how they are relating to this question, because in our day-to-day work, in many cases, people approach us and say, hey, Liat, this is a real issue in my system, or is this a false positive? And I'm just looking at my code and say, this is new code, I think this is a false positive, or I say, I'm sure this is okay, and this is. And then I asked my team, what do you think? What makes you think that a code is a problematic code, or this code is a false positive? And I collected the ideas, which is really straightforward. So one was, are there unit tests? Time from last fix, how many comments? The thought was that if there is a lot of comments, then it's so complicated. How long is the code? Entropy is a measure of complexity, and how much this validation lives in the system. So I start with feature extracting. That's mean taking all those ideas and just changing to a number. Part was just taking from the code. It's very easy to check how many words is in the code, or the entropy is straightforward. And some I took from the Git log. Apparently in the Git log, you can find a lot of very interesting data, like when this code was maintained and what was written on it, and etc. And I got the label from this code because we release new version every 5 to 6 weeks. I happen to have data that is Git label from every 6 weeks, so I can go back in the history and see if in my future there was a bug fix. So I have both data that I can check for or run the history, and I can know if I was right in my assumptions. So data look like that. In the end, tabular data, name for each validation, branch set date, all the dates here are in epoch, entropy, code line, and etc., and labeling. And here I did some linear regression. It looked promising, but not enough. So I asked my husband, which is expert in data science and algorithm developer from the Hebrew University and from Penn University, to help me do something interesting with this data. And he said, well, tabular data is my favorite topic. I'm actually just working on that. Just a word about tabular data. I asked my favorite LLM, that's easy, good for tabular data. And he said, well, LLM is not exactly for tabular data. And the reason is that neural networks are really good for features that has a close connection to each other, that has some connectivity. If you have a picture, the 2 pixels related to each other. But on tabular data, it's not exactly the case. So actually, this is still ongoing, very interesting research subject. For ML models, I think one of the leaders are XGBoost, which is a trees model. And actually, some people, this Benjamin thinks that XGBoost is all you need. And there are interesting papers about why LLM is still not there for tabular data. But I didn't just wanted to do a classifier. I wanted to have deep understanding of what make my code be reliable code. So here we wanted to have explainable models, models that can tell you the insights of your problem. So as for now, the non-explainable models in very big is dividing between linear models. You have points and you move a line. Piecewise, which means that you're learning where to cut your data. And inside of it, you have something like linear, but for multi-dimension. So it's not exactly linear, but we can think about it this way. And you have trees that is considered to be explainable as well. Trees is kind of thinking of radio buttons that you think of threshold, and then need to learn the threshold and learn the structure of the tree. The leading models are Lattice for pairwise and XGBoost. And trees is not so much easy for explainable. This is a picture from one of Google researcher, and it's explained that even small trees like this is not easy for understanding. So what we suggested, here comes Ofir's work. We improve those models by learning first the linear monotonics. So the idea that is in many cases, we know intuitively that a feature may either increase or decrease the phenomena. Adding constraints to ML is well known. The idea is that we first learned from a simple model and then added to the more complex models. And we both added the combination between trees and lattice, so it gives us a more. Okay, this is the results of our data. Another thing, just adding, I asked my husband not only giving me explainable, I wanted to have order. I want to click a number and know by order who is the validation that is most likely to have issues. So what we see here is the result of ordering. And we calculate here the area under the curve. So as if we were doing perfect, we will see it up because everything was in the beginning. And if we will do it without any randomly, we'll see it something like here. So everything that is more than 50% is really good. The dash one is the regular one. The lines is the improved one. And we see that results are much better with adding monotonic constraints. And if we even combine the trees and the piecewise, it's even much better. Okay. I was on time. OK, so demo-wise, this is a UI that it's a live demo, just the ML, for this model. So each parameter here can be changed. The app, we see the app part is this part is the features that increase the reliability, and those ones decrease the reliability of validation. And this is the probability to get to get a good results. And we see, for example, that if the code length is really short, we will get really good prediction of having good code. And what is else we see that we can see the changes of the other parameters according to the parameter that we change. So we don't just see the difference in the probability. We also see how each parameter affects all the other story. And the most important, the most interesting story was regarding the unit test. When changing the unit test to 1, it almost doesn't matter what you do on the other side. So even if your code length is really high and your entropy is really terrible, you still get really good results. Unit test wins again. OK, what about energy consumption? This was the part that actually blew my mind. All this playing with classical ML, I did on even on slower laptop. It took 2 or 3 minutes, even the training, and the inference part, we just saw it right now, it's seconds. Trying to do the same trick with LLM, I used the labs from my laptop couldn't even handle it, and in the company lab it took hours, and the result was not on the same level. Wow, this went really fast, so a lot of questions, I hope. Summary. Code quality against wins, and unit test is really important, and code quality is critical in the context of SRE tools. Git is more just than source control. It's a place when we can learn and understand better about our code. We saw that tabular methods for ML for tabular method is still growing and can be improved with monotonic constraints and with a combination of different methods. And I would like to thank to my husband that is all the ML with me, to my SRE group that contributes many of validation, and from Indian and Ranana group, and to Udi Bujko and Ovid or Felish that support this research. And thank you for joining these sessions. And that's it, I think. OK. Questions?
Where do you get, how easy is it to get the data to do this analysis?
How is it easy to get the data to do this analysis? Very easy.
Okay.
It took me.
Are you in GitHub or what's
This, I actually didn't even have to. This was from our local project. It's our local Git. I'm not sure which repository we used to store it, but from my point of view, I write a Linux command of git label fetch or something like that, and I have 100 lines of script the ChatGPT helped me write. And like this. Benny.
Did you check with different languages or different language paradigms?
No, this is the night job, so that's it. Yes, this is exactly the idea. What does it mean, repeat? Okay. So the question was if I can, correct me if I'm right, if I can use it for different kind of projects, right? Can I use it get the Git history from different project and see where is the painful part, right? I think yes, and this is the idea. So this is in, I had the chance to work in a project with a chunks that is easy to analyze, but I think that is correct for the larger, and I think totally this can be enlarged to to larger projects. No? So you ask if this enough big group for statistics. Yes, and actually this is one of the benefits of these models relatively to if you have a lot of parameters that you need to learn, you need to have larger data set. In this case, we took models which is more simple, and therefore this kind of data was enough, barely enough. So we needed to work a lot to make this simple be big enough for statistical. So in the beginning, I thought, hey, I have hundreds of validation. This is wonderful. And then my partner told me, yeah, this is small data set. But a small data set is something that you see a lot in life, in medicine, in everything. And this is the kind of method that is used in these cases. So actually, Ofir took the same method and worked on medical info and show almost the same result, that it's still reliable on this. But this is more or less the edge.
So, outcome is that you are able to identify potentially some variations that were negative, positives, or the outcome is some recommendations how to write those variations so that they are.
Well, we learned that unit test is, you cannot run from it, and it's the most important. So this is one thing that we learned. We learned that long code is not a good thing. Okay. We have a way to know which validation are the most dangerous one, which is really nice. What I always wanted to know to do with it is that when I'm telling someone you have a validation failed, I can tell him, and I'm correct in 80%. But this will be maybe future work or something like that. Not sure when, if. But this is where it's going. So when you need to get a decision, you need to know what is the chances you're right. Questions, more?
So just wondering, so who is doing this work now before we have the result of this wonderful, AI or machine learning agent? So this is now something that the QE people usually see that like.
You mean this daily, nightly? This.
So
Who is doing this? The nightly.
What part, like, what can you replace now or in the future with this?
Manual work.
So yeah. So what kind of manual work?
Well, I would want to say that one day LLM will replace it, but I don't believe it will happen totally. So we can do another step with LLM and grab more data from the features. But sometimes you need to get really deep into these details to know if this is real or false. For example, maybe the product we are changing decided to change its configuration file, and what was right version ago, now it's okay. What was a false there, now it's not a false. And sometimes you need just to go and talk with the QE or the engineers or etc. So I don't think that you will get to the same quality without any manual work, but I believe we can decrease it to the maximum.
Well, so currently, does your model return like a score or kind of a binary result?
A score. A score. Is it returning a binary or a score? So it's returning a score. I didn't want just classifier. I want a ranking, which is a bit harder.
And do you have a way, does it return also how sure it is of the score? You know?
How sure it is the score? I think not, but I'm not sure. I need to test. Okay. Questions? No? You're good?
The inputs for visualization you mentioned, for example, comments. I would understand how comments can impact the visualization.
Okay. The questions was how do we decide which heuristic to take for a feature extraction, right? I actually just asked my friend, how do you do it heuristically, intuitively, and just change it to code, whatever I thought that I wanted to do. There was several that I didn't put just because of time. But I just watched, and this is what we are doing intuitively, so why not do it numerically? Okay. More questions? No. Okay, so we are good. Thank you very much.